What if the next scientific breakthrough didn't come from a human scientist at all, but from a lab that runs itself? For centuries, science has been a deeply human journey. Brilliant minds in lab coats, running experiments late into the night. But today, something extraordinary is happening. Artificial intelligence is not just helping scientists, it's starting to become one. How AI became a scientist, the rise of self-driving labs. Welcome to the world of self-driving labs. Think of them like self-driving cars, but for science. These labs don't just automate tasks. They can design experiments, run them, analyze results, and plan the next step, all with minimal human input. Imagine shrinking decades of trial and error into months. This isn't just theory. At Stanford and the Chan Zuckerberg Biohub, researchers built an AI-driven lab to hunt for new medicines. When COVID-19 struck, this system tested billions of molecules virtually to find tiny proteins called nanobodies that could block the virus. In months, it generated candidates that would have taken years in a traditional lab. It's not just Stanford. Even labs around the world are building robot scientists. At the University of Liverpool, a mobile robo-chemist completed 688 experiments across 8 days and even discovered a catalyst on its own. In Amsterdam, a device called RoboChem optimizes 10 to 20 chemical reactions a week, work that would take human chemists months. And at NC State University, the FastCat system can analyze catalytic reactions in just 5 days, what used to take half a year with traditional methods. So how do these labs actually think? Picture a relay team. The AI brain plans what to test. The robotic hands carry out the experiments. And a data system keeps track of every result, learning what works and what doesn't. Over time, the system gets smarter, like Netflix recommendations, but instead of movies, it's experiments. Scientists even rank these labs by autonomy levels, from robots that just follow orders to labs that can design and run research cycles on their own. Right now, we're around level 3 or 4. Full AI scientist status is still in the future, but closer than ever. Why does this matter? First, it accelerates discovery. From vaccines to clean energy, the wait could shrink from decades to just years. Second, it handles the data deluge. Modern instruments produce more data in a week than scientists can analyze in a lifetime. AI finds patterns humans would miss. Third, it fixes a crisis in science: reproducibility. Many studies can't be repeated, but automated labs create consistent, reliable results. And here's something revolutionary: cloud-based AI labs. Imagine a student in Africa or South America logging in online and running world-class experiments on robotic labs thousands of miles away. Science could finally become truly global. But big questions remain. If an AI makes a discovery, who gets the credit? The machine? The programmers? The university? And can we really trust results from an AI black box we don't fully understand? Safety is another concern. What if a self-driving lab accidentally creates something harmful? That's why human oversight, accountability, and strong safeguards are non-negotiable. The rise of AI scientists isn't about replacing humans. It's about freeing us from repetitive tasks so we can focus on imagination, creativity, and the big questions only humans can ask. Together, humans and AI can open doors to discoveries we can't even imagine yet. What do you think? Would you trust an AI scientist to help find the next cure, the next energy source, or the next big invention? Share your thoughts below. And don't forget to like, subscribe, and join us on this journey into the future of science.